Okay, so I thought I'd share just a few tips about making a good project box, as it was referred to when I was starting out as a graduate. And basically, that was sort of an informal word for using one of these, which is called an enclosure, usually, if you're looking for it on various websites. And the point of it is that it's for keeping all the switches and buttons and, let's say, sort of microprocessors like Arduino or Raspberry Pi in a safe place. And I think even though if you're dealing with low voltage, and let's just say for the purposes of liability, I'm going to talk about low voltage, but obviously if you're suitably qualified, this would obviously apply to mains electricity as well. But the point being is that it just avoids essentially the mess and the chaos. And if you're building test rigs, what you find is that honestly, you lash something together quickly and you think that's going to be the end of it. And then at Dyson, time and time again, you'd sometimes get caught up in your own success and someone would be like, that's great, go run 20 more tests to validate it and understand the variables. And then you'd really regret that you'd built this thing together with duct tape and super glue, and it just meant that the whole thing was falling apart and introducing risk into the project, and then it would actually undo the in quotes speed that you just had from getting a kickstart. So I couldn't recommend it enough. If you can try to, this is probably like about £5. This is about a tenner. And I would really recommend it. Just takes a sort of nice little bit of professionalism to your work. So the first thing I should point out is that this is obviously a bit cheaper. And dare I say, if you're someone who has really ugly, crazy wiring, this one's for you. Or indeed, if you have a group of people who don't necessarily like to see the guts of projects, they just like to see nice, clean labels. And so I'm a big fan of these Dymo printer strips, and you can just put nice labels on, and then you can set up all your switches, along here in your controls, and it's all going to look very nice and neat and tidy. I would also say don't miss a trick to sometimes have a bit of fun. I keep these for the eccentric person who is maybe a sort of Top Gun fan who just loves this whole interaction. So I think you can choose very sort of boring dull switches, or you can choose the crazy silly ones. And I think there's always a bit of fun to be had depending on your audience. But of course, you're not trying to alienate people with something that also looks bonkers when maybe this is a bit more appropriate. Either way, those are kind of nice. I'll come back to those in a minute. So the first thing you'll probably end up doing is, if you're using the transparent one, is if you want people to see all the cool stuff and the processor working and even yourself being able to tell what's going on, this can be absolutely great. But don't forget, you can also flip it upside down. You could stick a bit of plastic on here and it will tidy it up as well and still give you the ability as the engineer or designer to check it out. So in case you hadn't wondered as well what this bit's for, this sort of spaghetti looking thing, this is basically like a sort of a squishy rope that goes round and seals it. So don't quote me on this, but this is called IP rated. And I think, if memory serves me correctly, that stands for ingress protection. Essentially, the first number is something to do with dust, and the second number is something to do with water. Don't quote me on it, look it up on Wikipedia. But essentially, if it helps you get an idea of how resilient this is to external conditions. So if you're just testing inside, probably something like an IP55 is going to be fine because it's not getting tons of dust and tons of water. But this is really good because I think this is a 66 or a 67, and that means I can basically have it outside in moderate rain, and it'll still be good. So I think, engineers tend to sort of over-spec things, and I think there's probably good reason for that, because sometimes you do find yourself designing, as I said, for one thing, success gets the better of you, and then you realise you got to test it in an entirely new environment. And so I generally think it's one of those things where people wince when they see you specifying a slightly more expensive thing, but then it ends up paying dividends later on when you've got good, robust builds. And when I say expense, I mean, I'm talking, this is still at the end of the day a £10 box. In contrast, I was working on a project which was basically 5 figures. So this is kind of inconsequential, really, in the grand scheme of things. So what's interesting to then look at is these little details here. Now these you can use as screw mounts, and so you can take something like a machine screw like this, or indeed a sort of a more like a wood screw or whatever, or a self tapper, and you can screw it in, and that will allow you to fix printed circuit boards. So it's a good idea to buy one of these early on in your project if you're designing a circuit board, because then you can fit these in. And of course, I'm not here speaking as a specialist electronics engineer. There's probably more in-depth videos on this, but basically these are quite useful. And of course, if they get in the way, you just hack them off with a Dremel, and as you can see, it's actually got no impact on the rest of the structural integrity, so it doesn't create a leak or anything like that. So the next thing, which I think to keep in context with the tools theme, if you haven't come across these step drills, as they're called, step drill bits, what they have is a number of the diameter of hole that they drill. Now you might be thinking, well, hold on, so this is probably like about £15, maybe £10 for a set of these high-speed steel ones. They really are an incredible thing, as that I'm not going to drill through this because it's brand new, but using an old bit of scrap here, you can see it just absolutely flies through like butter. And then you sometimes just rest it in and it smooths off and takes all the burrs. And so that's literally, don't even have to file or tidy that up. And of course you can come through from the other side and just take a little bit off as well if you wanted to square it up. And what this means is that it prepares the holes for things like this to go through. So you take a measurement of these things. Again, I find this is one of these, the reason I do these videos is because when you start out, you're embarrassed to ask about things like this. So at no point would I, when I started out my career, have guessed this thing is called a gland. I mean, I thought that was a biology term, and I still don't even quite know exactly why, other than there's this orifice that basically as you crank this down, it'll constrict. But, I mean, it almost feels more appropriate to call them sphincters. So, God knows, I still got to look that up. Maybe someone will comment. But you take a measurement of that, figure out what it is. I'm just going to guess it at the minute. Are we in? One more. So that's the beauty of the step drill. It's like definitely for the lazier engineer. And there we go. Goes in like a dream. And I should mention that the washer is obviously on the side where you want to stop water or anything coming in. So in this case, this would be the appropriate side. And so there, we take this off. You'd put your wires all in, keeping that on first. Crank that down. And again, a really good thing that we were always encouraged to at Dyson is if you can wrench a cable and it doesn't come loose, you've done a good job. And it's actually one of those things where engineers would regularly come up to your work, just yank on all the cables to try and politely say, mess with it. And if basically everything stood the test, that was considered good workmanship. Obviously, whether the circuitry and the diagram was appropriate is a different matter, but what you don't want is a cable just coming loose and say, two wires that shouldn't be touching. Even if it is low voltage, you could just mess up weeks of work by doing that. So these things, glands, come in all different shapes and sizes. That's pretty good. Step drill. And usually you get a 3-pack of these, I should add. I'll put a link below. And so you get all these different beefy sizes. They come with a straight cut, or this is a spiral cut. It just changes a little bit the feel of how you use it. So another one, if you haven't come across, if you've got a problem with a bunch of wires coming in, and sometimes you've just got this visible bit of metal or the strands. It's such a common thing when you've got these terminals and you're putting wires in, and there's just a risk one of them might fray and then touch the next one. And you think, it'll never happen to me. And then, of course, it does. So a really good habit is just to get into the habit of putting this stuff, which is called heat shrink. You put this over the wire, and then you grab either a cigarette lighter, or if you're feeling very flame averse, like a heat gun. But alternatively, a blowtorch is pretty good. And it's not for just sort of looking fancy. It's the nice thing about a blowtorch is that you can go very quickly, and it means that you're not overly heating the surrounding environment. As if you use a heat gun, you might actually, sorry about the door, you might actually end up sort of delaminating some of the soldering on one of the other PCB joints. So another thing, these sort of spade clips or terminals. Again, this is just a sort of another good reason of why you sort of take apart stuff. It's just that it's good to see how people have done things. So these are pretty cheap, and they haven't actually got what's called a locking detail. So when you put these in, they just stay in with friction. But some of the more advanced ones have a little pin that you press down there, and it goes into this hole, and it locks in so that you can't pull them apart. And again, if they're inside a closure, I think it's pretty safe to say they're not going to fall out. But if you were putting them on assembly, which was part of an assembly line where people were putting it together at speed, you might want to invest in that little bit extra cash. So again, there's tons of videos on how to use these, and I didn't think there's anything very special to show you that hasn't been shown already. But I kind of thought these are pretty cool, actually. So what these are, don't know what you call them, but this is a really cool tool. I'll see if I can bring it close. So there we go. See if it lines up. So what it does is it spirals round concentrically, a bit like a Helios ring on a camera, and then crunches. So what this means for all these little things is that you can poke 2 wires or more into these, and then bring it together, crimp it, and you'll get them. And what's great about this is that it means that you don't run the risk of putting strands together, which then, with sort of wear and tear, start to wiggle apart. And also, because you've got this sheath, this plastic bit, it also stops anything nearby from having that frayed copper strand risk of it touching and short-circuiting. So I think this is a bit of an unusual tool. I don't see this as commonly used, but I think it's a comparable price to the usual crimps that you get with this. And I've used it literally on a recent project, which is why I was prompted to do this video, as I just think, I know, whoever invented this is a bit genius, because it just works so effortlessly. And dare I say it, I think you have to be quite skilled to crimp these. You have to get just everything working nicely, or sometimes the wire slips loose. Whereas with this, I really would say they just feel idiot proof. It sort of essentially manages the pressure itself as well. Doesn't matter what size you put in, it'll induce the right amount of force onto it and stop when it's at the right amount of force and bite. So I think these, whatever they're called, circular terminals, absolutely best thing I ever invested in. So anyway, the obvious thing just to point out is that most of these things, you can see they've got a circular column which has a load of screw fittings, and you can see on here with a potentiometer, same sort of deal. The trick to realize is, of course, if you've got a square one, what you want to do is basically work out approximately this shape, and these little springy arms are what hold you into place. So you want to drill a hole and another hole, and then you either want to get a file or a little handsaw and basically cut between the 2 holes, and then a square file and take out the corners. And you don't need to be excessively accurate with this. You can also just bomb in with a Dremel or a rotary tool, and it'll get it as well. The downside is that if you're less than exacting, or you haven't, say, 3D printed this, so it's a nice accurate fit, they can actually just pop out. Now, if this is a 12 volt thing, probably no big deal. But if it's mains, I would say either, don't do it unless you're going to be really accurate. Otherwise that, or you could basically hot melt glue it in if you wanted to be extra secure as a workaround. But I would say that, that's why these are so popular with the holes, because as you can tell with this, you just bomb through. So yeah, I hope that's useful and gives a little bit of background of why you see maybe more experienced engineers using enclosures. And I think it's one of those things that will raise your game and give you, should we say, a little bit of confidence that when you also have to go back and change things, it's nice to know that essentially you haven't got to sort of reinvent the whole thing. There was a bit of a sort of saying at Dyson of, basically, I can't remember exactly, but the emphasis was try to avoid glue wherever possible. It isn't something that you can easily reverse or change. So I think that's why you see so many screws in the product. I think maybe some of it is to do with sustainability and the ability to have it easy to recycle. I think that's definitely a part of it, but it's also very much a product of the way the company tests and iterates. It's very much being able to take things off and try different pieces on. So I think in many ways this exemplifies that of keep things able to be disconnected and reconnected and iterated. So hope that's useful. Do post any questions or comments. Happy to do different variations of this. Thanks a lot for watching. Bye.